Right. Greetings, ladies and gentlemen. Welcome to this the ADAS Roundtable. So, when we first conceived a roundtable on the advanced driver assistance systems in March this year, we weren't quite prepared for the outbreak of the COVID-19 pandemic. The slowdown in the sector in the previous year wasn't enough to wreak havoc across all segments of the industry. The virus outbreak has forced economic, political, and social disruptions, unlike anything we have seen in the past, ruining businesses, human lives, and even homes. But the commitment that we had made wasn't one to give up on. Hence, we moved the roundtable to a virtual format, and I'm delighted to see so many of you log in today for our first ADAS roundtable powered by MathWorks. Welcome. It also gives me great pleasure to announce that we are also committed to launch a dedicated website on ADAS, which would go live in a month's time from now. And I invite each one of you to contribute your knowledge, information, case studies, white papers, or any other assets that you might have on the subject to make this a vibrant platform on anything and everything related to ADAS. Our intent is also to create a community of professionals who are working in this domain, and we would get going or get working on that the time we launch this website sometime early next month. If you look at your chat window now, you'll find a link on the MathWorks website that has content on many aspects of ADAS software development, from reference examples to user stories. Please make the best use of the assets there. I'll give you a few seconds to copy that link and keep it handy. Now, coming to our subject of discussion today, which is envisioning ADAS roadmap in India. The fact that India continues to contribute the most number of road accidents and fatalities worldwide is not lost on anyone. Introduction of ADAS technologies have enabled vehicle and pedestrian safety, as well as have improved driving experience. But there's a long way to go in this journey. The Indian government also a couple of years back announced or they started talking about introducing ADAS in all cars in India by 2022. When we look at some numbers, the ADAS market is estimated to grow at a CAGR of about 27% from 2019 up until 2027 for a 7-8 year period, from about 30 billion to about 135 billion. And with the ADAS domain, the software segment is estimated to be growing the fastest. To discuss how we can proceed in creating a ADAS roadmap and an ADAS roadmap in India, I have with me today 5 eminent speakers representing multiple stakeholders in the Indian automotive industry. Please join me in welcoming to the panel today Mr. Tarun Aggarwal, Executive Vice President, Engineering from Maruti Suzuki India. Welcome, Tarun. Ms. Bindu Santha Philip, General Manager, Automated Driving, Robert Bosch Engineering and Business Solutions. Bindu, it's wonderful to see to have you with us. We have Dr. Manaswini Rath. She is the Vice President and Global Head of Autonomous Driving at KPIT Technologies. Ms. Ujjwala Karle, she is the General Manager at ARAI. And our fifth panelist is Mr. Shanti Medasani. He's the Director of Engineering, Autonomous and Systems and Sensor Exploitation at MathWorks. Now, before I introduce our speakers in details, can I request my colleague Vivek to run the first poll of the day, and I request all of you to participate actively in the 3 polls that we will have today. Okay, so the question we asked is Indian consumers looks forward to ADAS features for safety and convenience and is willing to pay for them. We will give you another 5-10 seconds to fill in your answers. Yeah, okay. So 46% of our respondents feel they agree to this. 19% strongly agrees to this. 22% are neutral, and only 14% disagree. And there are no one in this audience who strongly disagrees with this question. So let me now introduce our speakers today. Mr. Tarun Aggarwal, he is the Executive Vice President Engineering at Maruti Suzuki India. He heads electrical and XEV and electronics division and the company and has been working with the company for more than 3 decades. He is responsible for undertaking key strategic initiatives in new technology areas in the field of vehicle, electrical, XEV, and electronics. Mr. Aggarwal leads a team of more than 120 engineers working across various functions of infotainment, wiring harness, switches, controllers, engine electrical, EV, and hybrid systems. At Maruti, he has served in several roles in areas of interior and body design, styling design, new model program management, and product strategy. He also carries extensive international product development experience while working at Suzuki Motor Corporation in Japan for more than 2 years. He has a mechanical engineering degree from the National Institute of Technology, Kurukshetra. Secondly, Ms. Bindu Santha Philip is the General Manager, Automated Driving at RBEI. She carries 24 years of experience in areas of engineering, design, and development. In her current role, she is responsible for driving her team in developing automated driving functions. Previously, she had worked as a senior design engineer, engine R&D at Ashok Leyland, wherein she worked on Euro 1 emission norms. She also worked for GE Medical Systems, where she was responsible for designing large medical devices as per FDA norms. Philip also had a work stint at Honeywell Technology Solutions Lab, where she led design teams in automotive, industrial, and aerospace applications. Next, we have Dr. Manaswini Rath. She is the Vice President and Global Head Autonomous Driving at KPIT Technologies. She carries more than 25 years of experience in the safety industry. She started the autonomous driving team with 20 members and today leads perhaps the world's largest autonomous driving team developing level 2 to level 5 software for autonomous driving. Her team comprises 2,000 engineers based in India, US, Europe, Japan, Korea, and China. Dr. Rath has developed and architected a platform for level 4 and level 5 autonomous driving and is responsible for a global list of customers, including BMW. She has done her PhD in metaphysics from the University of Metaphysics, Sedona, USA, an MBA in engineering management from Coventry University in the UK, and has done her Masters of Science in Industrial Engineering and Management from IIT Kharagpur. She has previously worked for reputed companies including Honeywell, General Motors, Infosys, Indian Railways, BEL, and has 22 plus patent applications and 60 plus publications in tech journals and conferences. Next up, we have Ms. Ujjwala Karle. She is the General Manager at ARAI and carries more than 25 years of experience in areas of automotive electric and electronics controls development, evaluation, and implementation. At ARAI, she is the functional head of the technology group working on new multi-domain technology areas such as ADAS, autonomous vehicles, IoT, electric vehicles, hybrid electric vehicles, data analytics, embedded control systems, etc. She has worked on implementation of innovative and indigenous systems with Indian use cases such as onboard diagnostics implementation for an OE, dual fuel retrofit electronic stability program for the SUV segment, technology demonstrators for series hybrid vehicles, as well as ESCV program. She holds a bachelor's degree in electrical and electronics from Savitri Phule Pune University and she has also published more than 30 technical papers and has a couple of Indian patents. Our final panelist today is Mr. Shanti Medasani. He's a director of engineering at MathWorks. He leads the autonomous systems and sensor processing group in Hyderabad. Shanti's research interests include autonomous vehicles, biologically inspired systems, computer vision, machine learning, pattern recognition, sensor processing, and robotics. He has over 60 issued patents and has published more work in numerous journals. Prior to joining MathWorks, Shanti was the Chief Technology Officer at Urmi Systems in Hyderabad and also worked as a senior research scientist at ARAI Labs in Malibu, USA. He has developed multiple image, video, SAR, and LiDAR-based recognition and learning algorithms for several companies such as ARAI Labs, GM, Raytheon, John Deere, Delphi, Volkswagen, Boeing, and DARPA. He is a senior member of IEEE and holds a PhD degree in computer engineering and computer science from the University of Missouri, Columbia. Next, we would soon be hearing from Mr. Sunil Motwani. He's the country manager, sales and service at MathWorks, managing sales-related activities for commercial customers in India. He has been at MathWorks since 2008, from the time it started operations in India. Prior to joining MathWorks, Sunil worked at Hewlett-Packard and Agilent Technologies, managing sales of test instruments for various industry segments in India, including aerospace and defense, communications, semiconductor, automotive, and industrial automation. He has more than 25 years of experience in sales of technology products across various regions within India, having been based at Mumbai, Delhi, Hyderabad, and Bangalore during this time. Sunil has a bachelor's degree in electronics engineering from Visvesvaraya National Institute of Technology, Nagpur, and a postgraduate diploma in software technology from National Center of Software Technology, Mumbai. Vivek, before I invite Sunil for his welcome address, can we have the second poll, please? So the question we asked was the skills needed by the auto industry for ADAS. Okay. So another 10 seconds before we move on. All right, Vivek, we can stop here. 36% of our respondents feel it's deep learning engineers. 28% has voted for advanced control engineers, and 20% have voted for simulation engineers. 8% have voted each for validation engineers, and I don't know. All right, thank you, Vivek. Now let's move on to the welcome address by Mr. Sunil Motwani. Before I invite Sunil to speak, many of you will know MathWorks. And for those who don't, MathWorks is the leading developer of mathematical computing software for engineers and scientists. It has deep roots in automotive, and top auto companies use MathWorks products for design and development of their vehicles. To hear a little more about MathWorks' perspective, let's invite Mr. Sunil Motwani, Country Manager, Sales and Service, to say a few words at the start of this panel discussion. Sunil?
Thank you, Rangshu. Can you hear me?
Yes, Sunil. Just a moment. Let me give you, yeah. Yes, Sunil. Can you please switch on your webcam? Yeah.
All right. Thanks, Devanshu, and good afternoon, everyone. It's really an honor to be associated with this roundtable, and it's my pleasure to welcome all the panelists and participants to this very special roundtable on ADAS. There can be no debate that ADAS is a megatrend in automotive industry today. It does bring in the promise of safer roads, but with it also brings in stringent demands for the safety of software, which exponentially increases the validation demands. And development and deployment of ADAS, needless to say, comes with its unique challenges, specifically around the wide spectrum of competencies and skills that organizations need to build. And it came out in the poll question that Devanshu just put up. Quite a lot was divided between advanced control engineers and deep learning engineers. So there is a wide spectrum of competencies and skills that organizations need today to build ADAS systems. Also, engineers need to deal with large amounts of data, both recorded as well as synthesized and generated in simulation, so that they can create scenarios, especially around edge cases, when you want to test and validate your complete system. It's really challenging indeed. Can we go to the next slide? So, well, you are all familiar about the auto industry ecosystem. We have OEMs like Maruti, tier one suppliers like Bosch, engineering services companies like KPIT, and regulatory authorities like ARAI. And along with this, we have software tool developers like MathWorks. We all play into this ecosystem. And today in this panel, we are really happy to have representation from each of these players who are part of this automotive ecosystem. From the perspective of deployment of ADAS systems, OEMs may want to really have deeper control and access to these systems, bringing in greater software focus. Tier ones may wear the hat of system integrators, putting together multiple sensors and electronics that goes with it. And tech service providers may really view it as an opportunity to gain more work and generate more business. While regulators will need to validate complex software algorithms that are used to build to safety regulations. At MathWorks, we really see one important thread that connects these different players, and that is simulation. Simulation can help OEMs design and test robust systems without waiting for vehicle prototypes. It can help tier one and tech services to develop and test software with higher accuracy that is needed for building such systems. For regulatory authorities, it would provide means to validating the complete system. So in summary, I strongly believe simulation will play an important role in homologation of ADAS as a system to be put up on a vehicle. At MathWorks, as Devanshu introduced, we have been building simulation tools, technologies, and solutions that enable adoption of model-based design, workflow, and methodology. I'm very happy to share with you all that automotive industry really has been at the forefront in adopting this model-based design methodology for embedded software design for many years in multiple areas, including electrification and automated driving. For those who do not know about MathWorks, very briefly, I can talk about two platform products that MathWorks builds, MATLAB and Simulink. MATLAB is really a platform product for us for technical computing and data science related technologies, whereas Simulink is a platform that enables model-based design in development of embedded software. MathWorks has been building these two products along with many other vertical products, which offer solutions around deep learning technologies, automated driving technologies like sensor fusion and tracking and navigation, to name a few. So in the context of automated driving or ADAS systems, typically engineers would be working towards building three different types of subsystems. And can we go to the next slide, Devanshu? And you all would be familiar with if you are working in the area of ADAS or automated driving. Perception, planning, and control are three things that come together to build an ADAS system. And as engineers, we also need to ensure that we integrate and test these systems together. And for testing these systems, we also need to, in the simulation environment, synthesize the scenarios in which these systems will be working together with the vehicle. That means we need to have a platform on which we can build algorithms for perception planning. That's where MATLAB plays an important role. And Simulink as a platform allows you to bring all these things together on one platform, along with uh, you know, test vectors that you can use to generate different test cases and analyze how the entire system would behave, along with the vehicle dynamics as well as vehicle controls. So that's it. What I wanted to set the context for the panel to take this discussion forward. But before I hand it over back to Devanshu, I would like to thank ATR to provide us with this platform to bring industry leaders while we speak about ADAS today. And we would like this dialogue to keep going on for many other topics in future which are relevant for automotive industry, like electrification, data sciences, and digital transformation, to name a few. Finally, I really look forward to learning on how the different pieces of ADAS ecosystem mesh together, and the deep perspective from each of the panelists would certainly help us get that understanding. And together, we would like to see and envision the roadmap for ADAS in India. Over to you, Devanshu.
Thank you. Thank you, Sunil. Truly appreciate your sharing your perspectives with us. Thanks very much. Vivek, before we move to the panel discussion, can we have our final poll of the day, please? All right. The final question we asked was about the concerns with the end user of a fully automated or self-driving cars. Okay. Another 5 seconds. All right. An overwhelming 86% of our respondents feel the Indian environment is too complex for self-driving cars. 7% aren't sure about sensor technology or its maturity, and while the remaining 3 are in the very low voting range of 3% and 1%. So thank you once again, and we would now move on to our discussion of the day today. Yeah, yes, all of us seem to be here. Bindu, if we can have you back on screen. Yes, wonderful. So yeah, so thank you, the respondents for also kind of participating in our polls. Now, to begin the formal discussion of the day, may I start with request all of you to share your initial perspectives on the subject, envisioning an ADAS roadmap for India. Tarun, can I start off with you?
Yeah. Good afternoon, everybody. I don't have a prepared speech. I think one thing which is very important is that all of us need to agree. I think we are various stakeholders. What is it that we want to achieve? And I sometimes do feel that, there's a little bit of people have different goals. Maybe some people are more keen on technology, some people are more keen on saving lives. So I think before we set a roadmap, it is very important that what we want to do. Perhaps everybody agrees that India has the worst record as far as losing lives is concerned. Okay, we have perhaps 1% of the maybe vehicles and maybe 6% of the deaths in the world, which is not very, I mean, something we are proud about. So I think first thing is that I think all of us agree that we do need to save lives. And also, I mean, our perspective is that saving lives is not going to happen just by introducing a particular technology. It has to be a wholesome exercise. And I think in the last few years, government has taken a lot of initiatives in that direction. And the new Motor Vehicle Act, I think if it is implemented properly, could be the biggest change which can happen. and the 4 E's which government has been promoting, I mean, if they are actually implemented, it can really save a lot of lives. Also, I think one more point which is very important, which came out from the poll, is that everybody understands the challenges of India are very different from anywhere else in the world. So what people feel about fully autonomous vehicles or something, I think same is true for driver assistance as well. Because autonomous vehicles is a combination of all the technologies which go into driver assistance. So I think any of those technologies to work in Indian conditions is a big challenge. I think we have very learned panelists, perhaps they can throw more light on that. But I think whatever little work we have done in Indian conditions, we have tried vehicles which we sell in Europe and other markets in India. It can be really challenging. And finally, one point I want to make is about cost. I think in India, perhaps we make, if you leave China aside, one of the most inexpensive vehicles in the world. Okay, perhaps nowhere you would have vehicles which meet all requirements, mainstream vehicles selling maybe as less as $3,500 or something. Typically in mature markets, if you want to add some kind of autonomous or ADAS package onto a vehicle, it will maybe cost you more than $3,000. So we have to keep in mind that what's the right balance of what is the best way for India to save lives, and in that I also feel that driver assistance does play a role, but what is the right time and what is the technology, I think we need to work together to find that out. Dipanshu, over to you.
Yep. Okay. Thank you, Tarun, for your initial remarks. Can I now go over to Bindu for your initial thoughts on the subject?
Yeah, so hi everyone. ADAS for India. That is a topic very close to a lot of our hearts, I think. Is it possible? Is it practical? What would be a help to the driver and what would turn out to be an actual nuisance? So when Tarun said he has tested some cars, that they use that are meant for export markets, but if they run in India, how does it go, right? So maybe later, Tarun, you could give us some examples, right? So I think that for us, it is at Bosch to do something for India is really high in priority. There are a lot of discussions going on. The first thing that we thought would be very useful is to look at something that would give us some amount of experiential learning, right? So the team here, we put together a program called Drishti. And Drishti was typically to let's see India through the eyes of a Bosch camera, right? Let's see how, what are the patterns, what are the behaviors that we find out, what are the objects that we see. As a driver, you're very tuned to avoid certain things, but as a system, as a ADAS system, what are the challenges you will face to see the same scenarios through that? So this was something that we did. It was quite a big project where we had our vehicles fitted with our sensors and sent them through India. We covered 10,000 kilometers by each vehicle, covering both urban areas and highway. And there were a lot of learnings through this. We look at urban areas where you have so much more traffic and there's a lot of, let's say, adjusted chaos that has to be dealt with. But you have lower speed. So I think you have better time to respond as a driver. On the highway, what we saw was much more encouraging in terms of we are seeing standard features on the road. But the speeds are higher, of course, and so your time to respond also becomes a critical to quality or a KPI there. In terms of enablers, right? So I'm just going through what we saw, right? What really would help, it would be the standardization of the road features, of how do you implement road features, whether they are speed humps, whether they are barriers that we use. We have these barriers that suddenly prop up in the middle of a highway. Lane markings, are they visible? Can I recognize all the objects that we see on the roads, which are typical for other countries? Road signs standardization, So a lot of these things came up. We had potholes, new objects for a lot of systems, right? So so in India, the challenge, as everybody said, right, would be the variety of the use cases that you have to handle. You have a lot of variety of vehicle types, right? In very interestingly, driver behavior, everybody drives differently. So your ability of your system to respond to this, no matter how many sensors you put in, right, the more you are adding into these use cases, the more complex is your system, the more complex your algorithms get, whether it is in each of that perception, behavior, or planning, and and the final actuation. It gets a little bit complicated if you keep on designing for let's say balcony cases, or those very specific use cases that come in because it is typical for India. So standardization of road features really helps. It looks quite plausible for highways. And if you were to streamline it much better, I think, like it was said earlier, it is not going to take only just one part of the industry to make this work. It's just the whole ecosystem coming together to make it work. The other thing we see is so we're talking of different object classes, right? In addition to this, we are also looking at the existing software that is available, existing algorithms, existing sensors. How do you you need to make adaptations for them to work for India. And so I would say that what's very critical for us is to be able to get this all together, to be able to predict something consistently, right? To be able to respond consistently to the prediction. These are things that we have to build in and ensure the safety comes through. India has always been legislation driven, whether we talk about the BS6 norms or we talk about the ABS that came in, and hopefully ESP and AEB, and the whole thing comes through. And once this comes in, a certain understanding of how the need to standardize a lot of the infrastructure we have comes to the forefront. So I think in short, there are challenges for us to achieve or to make something go on the road with ADAS without it becoming a nuisance to the driver, for it to actually be used for the intended function. But and I think that with these kind of forums, hopefully we get to discuss more of this openly and actually solve some problems. Thank you.
Thank you, Bindu. Thanks for those initial very interesting perspectives. Can I now move on to Manaswini? Manaswini, for your initial comments on the subject.
Yeah, sure. I think the previous two speakers already covered a lot. So what I believe is ADAS is a need for India, as we are talking about accidents versus the not disciplined drive. So that risk is very high here. That's where deaths are more, accidents are more. So to mitigate the risk, safety system is critical and it's a need. Now, what we do to bring this as a reality, right? So I think 2-3 aspects other than the technology of ADAS. I think all of us are representing the best of the best organization. And as Bindu said, I agree, we know how to tweak the algorithms. It can be done. I mean, when ADAS was spelled, nobody knew that even in global scenario where lanes are visible and objects are defined, it will work or not, but it has been proven. So it would work in the variations and a lot of different objects and all. But I think there is a need more to the technology, right? It is infrastructure. Infrastructure plays a big role. It's not the way India is changing. All of us are witnessing from last few years. It's not impossible to build a minimum infrastructure of having a lane and forcing a disciplined drive in high speed in highways and all that, right? If India can make everybody shut down and lock down with crores of people for 2 months, I think everything is possible. And forcing a disciplined drive is also possible. I get to believe now, because I could not believe what happened in last 2 months in India nobody abide any rules and people are at home. Maybe it is matter of life and death, but same thing we are talking, ADAS is also matter of life and death. And so discipline drive is one, infrastructure and regulation for discipline drive, and B is awareness. The greatest challenge in India is, are the drivers aware about what to take care while on the road, right? I mean, if you have a steering, you are just getting onto the road, because we can get a license with anything we know how. So that is important. Technology can definitely solve India's problem. That's my belief. And in KPIT, we have been working for Indian scenario, and we have the capability to localize the global solutions for India. We need OEMs help, where I would talk in the next few questions how OEMs should be taking the lead role there. But it is possible. But at the same time, we need infrastructure, regulations, and awareness among the people as well to bring ADAS. And that's the need, and it has to come. And all of us have to make it.
Thank you. Thank you, Manaswini, for your initial comment. I would move over to Ujjwala. Ujjwala, your initial comments. I also have, you have a presentation. Would you want me to run
no,
that?
Dipanshu will, no, I'll continue with the comments only,
Okay.
I believe.
All right.
If necessary, we'll show another slide, because a lot of things have been covered by earlier speakers. So I agree with first thing, that safety drives. I think that's what I'm saying. Why we are really looking at ADAS is the safety solutions. We are all agreeing it is very complex in Indian context. So as I am also looking at how to validate. See what something Tarun expressed, that he has tested a few vehicles. We also have tested a few vehicles, and really have found challenges while doing that. So validation is one very critical point somebody has to look into. How to ensure that the systems which will run in all the conditions which we have not really gone through some situations, and the systems which are proven in the international context, they are entirely different in the Indian use cases. Everybody discuss about that, about the different use cases in India, not only vehicles, social behavior, and infrastructure, every way. One point which we have not looked into, the 80% accidents today what we have are from because of the driver. That is what our government data shows. So ADAS is required, but what we are not looked into is which types of vehicles. Do we require ADAS, or do we require advanced rider assistance systems? Do we require systems for the public, commercial vehicles beyond cars? Like cars, we can really, the additional cost probably still people can afford and go to it. But what will happen to the public vehicles or the commercial vehicles, according to me, and the two-wheelers, where they are, the numbers, if you look into 75% still the two-wheelers in the market. The VKT, what we call vehicle kilometers traveled by the different category of vehicles we take, it's more than 40% is covered by the commercial vehicles today. So in such cases, we need the solutions for them. So Indian solutions have to be focused or more concentrated towards which is going to have a more effectiveness. That's what actually even Tarun mentioned. What is that is going to be very successful or useful for us. So that is how also it is different. So we need solutions for these kind of problem statements that we are looking at. I very well agree with Manaswini saying that it's positivity that she has come across, that things would change, and we all have experiencing that change. But I think it's going to take time for the changes, and those changes, how we are going to, are we going to change even the technology and adapt that technology for the Indian context is a challenge. And that is what I believe the opportunity is for us. And coming to verification validation, I believe that is where the ARAI also has started the program. We call it as more a Swayam Go program. So when we call autonomous is Swayam Go. So autonomous is extreme, but we believe that autonomous functions are very, very important. ADAS is nothing but level 2 and beyond is having those functions autonomous. So we have also covered a lot of data. We have labeled different vehicle classes, infrastructure across India. And what we believe is, as ARAI, we should enable these developments happening in Indian context. So giving Indian database to others, making that available so that people can develop and validate. Can we give a platform where people can can really try their algorithms? Build a simulation platform where people can come and try their algorithms. Even try to build a driver in loop simulations, because which is very important. See, today, anything on a safety, I strongly believe safety solutions cannot be directly driven on the road. There has to be simulation which has to happen in the lab. So how the scenarios can be brought in the labs. And in beyond that, because ADAS has intervention, how the ADAS takes over and relieves, as a driver has a connect to it, how driver responds to it is really important. In such cases, the driver in loop conditions, or taking a driver in loop, is very, very important in looking at his perception, how he takes it, how he responds to it. And that is where I think validation, apart from the development, a lot of people are there. Validation is a very, very important phenomena.
Right.
So many people want to drive through regulations. It is not just going to be very easy to have Euro 6 equivalent to BS6 for the Indian conditions. We have been still currently discussing the AAB regulations. Can the European AAB regulations be directly implemented in the Indian context? We are debating, we have a challenge is creating our own use cases for that. And how, even you take only vehicle dynamics part of it, overloading, how it will really, we are talking about M2, N2 category or the commercial vehicle segment. How, if we have overloaded vehicles, how the AAB will respond with the braking taking over? How use cases of overtaking would be entirely different. And that is where the criticality or the differentiation as compared to the other regulations which we have brought in here, and where the safety plays in, is very, very entirely different. And I believe it's collaborative efforts of everyone which will make this successful. Thanks everyone.
That's a fair point that you bring about collaboration. Our next speaker is Mr. Shanti Medasani from MathWorks. Shanti, for your comments on the subject. You have a presentation, so let me give you access to.
Thank you.
Yeah.
Can you see my screen?
Yes. Yes, we can see your screen.
Okay. Good afternoon. So there has been tremendous progress worldwide in the attempt to build autonomous systems, and folks have already spoken before. Here is one example to showcase the current state of the art. So all this is happening in fairly structured environments, I would say, of course, with a human behind the wheel for backup. All of us would agree that this is tremendous progress. But the problem of building such complex systems is, however, far from solved, as many of you have already spoken. In this video, you can see several differences when compared with the structured environments in the earlier video. So there is chaos, traffic in disarray. You can see many corner cases and anomalous situations here. And autonomous systems must be situationally aware and capable of navigating through such contingencies. So we have a lot more to do before we can say the problem is solved. In terms of challenges in adoption, I think there are several we still need to overcome. So things like precise sensors at economically viable costs that operate in all weather conditions, robustness through perception and sensor fusion. Now, a major part of the autonomous vehicles is software. So we need strong disruptive thoughts, I feel, in efficiently fusing the rigorous systematic approaches to software development with the oodles of legacy experience we have in verification and validation. We would also need specialized processing hardware to handle the suite of sensors in a very performant way. Like Ujjwala was saying, regulation is going to be very important. And in addition, I feel transparency and trust will be the key to adoption. Leveraging the data that we are getting from the sensors so we can build these robust and resilient systems that work in conditions they have not seen before is also going to be the key. Now, for the specific local conditions, the lack of maps, the irregular compliance that many of the panelists have referred to, the infrastructure limitations, and of course, economic compulsions, these are challenges that we have to overcome. So the SAE defines 5 levels of autonomy, and activity in this domain is getting polarized into 2 groups. So the cost of developing L4 plus systems is getting quite prohibitive, and we feel automotive leaders are forming partnerships due to the uncertainty of that horizon. The good thing though is that the experience and lessons that are being learned from the L4 plus activities are now being deployed into L2 plus activities, which is the ADAS part that we are talking about. So companies are now beginning to relook at new and robust ways to enabling resilient ADAS solutions. So we expect to see forward collision warning, cruise control, AEB, lane assist, driver monitoring, and several other applications get adopted mass market as they evolve with increased adoption and sophistication. And these are critically needed because they have a huge potential to save lives. For building these resilient systems though, many of you have read of millions of miles of testing that's needed, but on-road testing is pretty much impossible at that scale. So virtual testing at scale is the need of the hour, and this is going to reduce hazard and costs in on-road testing, debug and replace simulations for failure analysis, assess the performance in some specific corner cases, and of course manage the overall system complexity. Sunil has shown this slide. So automotive driving engineers use our tools to understand the real world and leverage the capabilities to build parts of the stack or the complete stack and verify the functionality. Specifically, here is a representative Simulink model of a highway lane following application that's built using components that we ship in the automated driving and model predictive control toolboxes. And just in terms of annotation of these different blocks, you can see how sensors come into play, how the scenario enacts out, data is produced, the data is exploited by the perception and sensor fusion modules. This in turn is exploited by the lane following controller, and along with the vehicle dynamics module, it completes the loop. You can measure system level metrics like lateral deviation and time gap, and these can be logged and observed and processed. This test bench is now a virtual test bed that you can simulate, reuse, apply to many other scenarios, and so on. So the video that I'm showing is the result of a run of that virtual test bed. So you can see 2 different views, one from the camera and one from a chase view of the car. You can log all of the metrics that you're computing for each of these runs, collate that information, and figure out how well you performed over time on one scenario or an ensemble of scenarios. So the virtual testing framework that's going to be very necessary for some of the resilient ADAS solutions that we're talking about. This involves creating scenarios or building these scenarios from real world data that we have logged, rigorously evaluating any of the applications that I just described on many such scenarios and their variants, and using the performance metrics to automate the regression testing process. Our belief is that a major portion of this development cycle, maybe 70% or more, will be in the virtual testing domain, and the last mile will focus on the real world testing, significantly improving and accelerating the current processes. So we've talked about autonomous systems not getting adopted at the expected pace. The complexity of these systems requires expressive modeling capability, the ability to simulate countless scenarios, the ability to generate performant code, and of course rigorously verify and certify. So the major bottleneck in putting together these software-rich systems, everyone is realizing, is actually in writing, testing, and certifying of this incredibly complex software. So we believe model-based design is the technology that can accelerate the path to adoption for these technologies and pop open this bottleneck. So considering the rich history MathWorks has in developing simulation tools, we are partnering with several automotive and tech industries, and we are committed to providing tools that will collectively enable us to systematically use the data and models, and of course simulate all the way from system components to complete systems. Thank you.
Thank you, Shanti. Appreciate your presentation. We would now move on to the Q&A session, and so the question that I have for Tarun, I mean, you talked about you gave a perspective about how Maruti or how Suzuki is going about development of ADAS solutions. Now, the question that I have is, how will the collaboration between OEM and tier ones change, let's say, for the development of ADAS systems?
I think I would not say it will change. I think it's a must, and I mean, for many other complex systems, traditionally we work with suppliers. For example, I'll give you an example of engine management or something. So traditionally, core engine management systems have been developed by suppliers, and we have been working with them for years to develop new systems. So similarly, or actually even higher level of collaboration would be required with suppliers. I think to work with it, OEMs typically would never develop sensors and stuff like that. Maybe a few may, but generally they would not. So I think we will have to rely on them for the technology. Also, any new technology, I think multiple sources of learning come into play. So a typical tier one works in multiple markets and with multiple OEMs, and I'm sure the systems are matured based on that. So once the tier one works with other people, they know how come. And similarly, we have the experience of vehicles in the markets which we know best. So I think combining our experience of knowing the market, understanding the user requirements, and the tier one's know-how. And as Shanti mentioned, I think that this is an area where simulation will play a very, very key role.
Right.
I think other people also mentioned that. I think the combination of such tools and combination of OEM and tier one, and maybe some technology partners together will be able to develop a relevant system. But having said that, the biggest partner is the other infrastructure which is required to make it possible. I think without that, anyway, it is impossible to go on this, frankly. However we may wish, Indian conditions are really severe. Somebody was very, very hopeful. I'm impressed by the positivity, but the lockdown has opened in Gurgaon and I drive to work every other day. Same people are back on the road.
Well, so what Tarun, what you were also talking about, and like some of our other panelists have also said, is this would include or this would need collaborative work among all stakeholders, and you talked about the infrastructure part as well. So Bindu, from a tier one perspective, if you could also bring in, how do you really, specific to ADAS, what's the kind of relationship do you see working out between different stakeholders when we talk of developing or finding out solutions for the different problems that we seem to have?
I think ADAS has opened up a lot of different working models. Yeah, because what everybody is realizing, and I think someone brought up the topic about even tie-ups, yeah, between OEMs and first tier one, and with let's say third-party technology partners, right? So it's actually just a whole chain of value that you have to build up, and everybody brings a certain value to that pipeline or to that delivery pipeline or that chain that we're trying to build. So that is one thing we are seeing and we are actively pursuing is if we were to say with OEMs, what we would like to do, and we are in discussions with some of them, are about study projects, right? To evaluate together. Because like you say, it is the whole thing starting from your sensors, your fusion, your planning, and your actuation, which is basically your control. And and the vehicle dynamics that come into it, and everything have their standards. For example, the NCAP standards, for example, there are certain specs that are there to protect also the person that is in the car, right? And not only the person that's on the road. So when you have to bring all this together and still make a working case, then it means that we have to do the studies together. We have to be able to bring together where do we see are those core areas that need fine tuning or adjustment or a basic understanding of the challenges. That is very key. It is a journey together. What do third party or let's say alternate technology partners bring in is there are certain core competencies that they have developed, niche areas. And I'm speaking purely from technology point of view. I'm not covering infrastructure or things like that. But there are these niche areas that could be very particular to solving one particular problem, but you need to bring them in. So these are the different methods that I am seeing have brought a lot of change that earlier were traditional, make it all within, right? Everything we do from scratch. We build it all from scratch. For example, even when we talk about simulation, which are the toolkits that we would like to use, which are those partners that we would like to partner with to enable simulation and give you an end-to-end simulation at all levels. We're starting from unit testing all the way to the top, and system testing. Very challenging, and I thought Shanti brought that up also, was the scenario simulations. When do you say testing is sufficient, right? When do you say a simulation, how many simulation runs must you run to be able to cover all the areas? So I think when this whole thing has to come step by step, we have to realize that the engagement models are very different nowadays, and realize that you don't have to do it all internally. I think, and everybody brings a certain piece to the puzzle. So I think that would be the view we take.
Thank you. Manaswini, the question that I have for you is, when we look at the global ADAS economy, what are the kind of opportunities that you see for Indian players? You had you are a global head of the organization for autonomous driving with representations across the globe. So what is your view on that?
Yeah, so I think India can play a big role in the whole global ADAS economy, if you say in that role, for the reason that two things are very prominent, which India could do, because that is our strength. First and foremost, that all of us acknowledge that be it ADAS or autonomous driving, the majority of the engineering is software. Unlike other systems, there is a play of hardware, but the majority of it is software. And we being the highest talent pool, right, in India, and contributing to software, the contribution could be significant, first thing. And second thing, as everybody is bringing out the importance of virtual simulation or virtual validation, and I completely agree, because I was in the ISO 26262 committee prior several years when it was in the formulation. So I understand safety very well. So the validation is 45 to 50% of the whole development, what we are saying. And KPIT being real world leader in this simulation and virtual validation, we have several patents, and very early we introduced several framework tools and solutions in this area globally. Today, say any OEM in across the world use our technology and services in this world. So there is a highest possibility that India could be a test house, because it is simulation, because it is virtual, right? We do not need a Europe road to test the ADAS applications and ADAS functions. We just need the videos and the conditions captured and known, the data. So otherwise we could build the whole simulation environment, we could build the whole infrastructure for several OEMs and do this together. Now I would like to bring one fact, to your previous question also, how the ecosystem partnership is evolving in ADAS. Unlike other systems, at least ADAS has introduced a different ecosystem model, right? The OEMs and tier ones are not having a supplier relationship anymore. It's more of a partner relationship. And if you know, we are engaged in the largest program of ADAS in Germany, where 3 OEMs are collaborated and several tier ones, and we are also technology partner there. So it's a collaboration between the technology partners, tier ones, and OEMs, and all are trying to share the risk and the investment, and also contributing to the whole solution. So coming back to India in this economy, software development, which is the ADAS AD algorithms and features, we can contribute a lot by really utilizing the talent pool. We have to start at academics, like in engineering, where all these skills are taught, and bring that for future as the craftsmanship of software and things like that. And second is, we could really be big as a test house to do virtual simulation and validation for across the globe problem, because we don't need real road testing, which can be done virtually, and in India it could be really done end to end in the simulation. And we are taking a lot of steps in that, and that's how it can contribute a lot to this.
Sure. Thank you. Ujjwala, I come to you with a question on when we talk of homologation. Of course, physical homologation is one, but how do you perceive the role of simulation specific for ADAS development, homologation for simulation, using simulation, that is? How do you perceive that?
I think as ADAS becomes practical in Indian conditions, I think simulation has a role to play. Take it verification, validation to homologation, because homologation you can do for one test, one use case. Even we go to a global practices that people are talking about. There is a global JRVA, where autonomous vehicle testing is being discussed. They have clearly put in the pyramid or the 3 verticals, where they are talking about you should start with simulation or the assessment part using SIL, HIL, and even driver in loop. Next phase becomes actually on-track testing, where the selected test cases can be done at the track level. And third is again going back to the world and taking back the feedback. So this whole circle has to be always completed, and that's how it becomes more complex when it comes to certification or testing of the ADAS systems or validation of the ADAS systems. It's not that I've been talking to a few international experts, and they've been talking, we are really having challenge because the systems are real already on the field. Whatever certificate that we are signing, is it really the work that we are doing? That's because we don't know whether we have covered all the use cases. Those will be covered in the part. So there has to be a real big full matrix test cases. If you have to run, we have to go with the simulation. Part of that selection could go to the at different levels. Some could be SIL, some could be HIL, and further could be on the roads or on the track. And track also, as we require special infrastructure for the roads, the track also requires different infrastructure. So creating those tracks and having those parts, and then going back to the roads, again taking the feedbacks and going back. So this whole circle will be the part of homologation. We can't really go and say that one test, it's over.
Okay. All right. Shanti, would you like to add to that the kind of the role that simulation would increasingly play in development of ADAS solutions in the future?
Yeah, absolutely. I am very passionate about that. I like biological systems, and nature has shown us what iterations can do to different species. So over time, we've all evolved into however we have turned out. So in the same way, I feel autonomous systems need a lot more iterations under their belt. And this cannot be done by getting physical on the ground, on roads. We need to do this in simulation, because with the help of cloud, we may be able to accelerate the ability to iterate and produce better and better models. And that is what I think most people are aspiring to do. And that's what is going to be our pathway to evolving better systems. So this testing is going to be scalable because of that. And it will really accelerate our advancement in this area. Given that India has very narrow safety bubbles, so the safety margins from one actor to the other on a road is very minimal compared to other societies. So we need much higher precision and tolerance to be handled here. So that's going to be very important. One other aspect in terms of making simulation the cornerstone is what Ujjwala was talking about is the standardization. How do we come up with like NCAP, Euro NCAP scenarios? Are there specific scenarios we could incrementally build for Indian conditions that ramps up all the actors into multiple steady state levels that they're progressing from one to the other? And how do we put together this and use that as a benchmark? So even OEMs and tier ones can share that to assess the quality of whatever dialogue they're engaging in, and regulation authorities can use that to certify performance at least a virtual level. So I think these are going to be very important as we iterate to a better autonomous system.
Excellent. My next question is, Tarun, if you could comment on the emerging skills that engineers should focus on, specifically to the ADAS development in the coming times. And Manaswini, you can comment on it as well, because you also talked about the need to educate drivers. So it's not just about offering technologies, but also driver education, which becomes becomes paramount important. Tarun? Tarun, can you hear me?
Sorry, my microphone was off. Sorry.
Okay.
Okay. I think I may not be the best person to comment on skills. We have a very small team, what we do. But few things I think which we learned by doing initial work is that overall system level understanding is very important. Okay, and to be able to understand the system, and as people said that in today's world, to be able to model and then take the next step is important. So I think we have people who are, I think, who understand vehicles, and then they've been trained in the last 3-4 years to do this work. I don't think most of the people who work in this area are from electronics or computers background. But I think depending on the core area of their interest and the job requirement, they gradually get into a particular stream and specialize into that. I think that's what happens in most places. And India also will ensure that people will get into those areas and specialize. And as a country, we make perhaps the most software in the world, and we use similar skills in many other domains. So I don't see personally that as a challenge, I think. Okay, we have enough engineers, and I think if you're ready to train them, they could be trained reasonably quickly and do the job. Just making one more point based on some other, I think, discussion. There was a very interesting point regarding creating scenarios. I think that's one area where everybody needs to collaborate and work. There is a lot of talk about creating regulations and cutting and pasting, bringing some regulation which was made in Europe maybe 10 years ago, and based on that, bringing something in India for heavy vehicles or something. To my mind, I think that's not a good solution for India. We have to have a logical grounds-up approach in analyzing the accidents, and from there figuring out that which scenario perhaps is maybe the lowest hanging fruit for India, which will save maximum lives, and then attack that and gradually take it one step higher. Okay, so I think that approach is very important to actually create a roadmap or a framework based on which we make a future plan for India. Even though people very loosely say data is oil, but I think India is a very poor country as far as India specific data is concerned. Same is true about accidents, actually.
Yeah.
So I think that's one area where we can start and actually work together. Okay. I mean, there is a consortium of RASI, which I think many of us are part of that, and we look at that data. Some of the interesting things which came out in the data was that I was looking at, we analyzed all the M1, the passenger car accidents, and typically there are around 27,000 accidents in a year. And what we analyzed was that maybe around 8,000 to 9,000 accidents or lives could have been saved if people were wearing front and rear seat belts both. And of course, the modern regulations of offset crash were there. And maybe further 1/3 could have been saved if people are driving at right speed. And then next 1/3, perhaps the kind of technology we are talking about would come into play. And I think in India, to save accidents, each has its place. So we have to do all the things to ensure that we actually reduce the fatalities on the road. Sorry, I think I went a little off track.
No, but absolutely fair points that you make, Tarun. Manaswini, if you could add to that.
Yeah, coming back to the skills, right? We are talking, and your pool already had listed few of them, right? Be it the AI, machine learning, deep learning, to advanced control engineering, test engineering, your software languages and all. So I want to bring something very interesting which we have learned, right? Working with the best of the best in ADAS globally. So even though we are the largest number of engineers making software and largest number of engineering institutes and all that, I think when it comes to develop ADAS or autonomous solution, we are dealing with the highest complex software here. And the why I say highest complex is safety makes it more complex, right? There cannot be any defect in the way that we make the software, neither during the first drive or later. So that calls for a real skill of software engineering. In India, if you see, we mostly in the skill focus on learning a language, right? I'm a C engineer, C++ engineer, or a Java engineer, or so and so forth. If you see how the global engineers learn the technology and all, they are very good at software engineering. The language comes as a secondary skill for them, right? That is something we have observed is little bit needs improvement in India, that we have to think through that. So a lot of skills are needed in ADAS, starting from AI to normal, the traditional software languages to simulation. Same way, I give an example. I mean, just doing simulation or testing tools and infrastructure we are talking about, there are a lot of ecosystem players like cloud player, data, curing, a lot of players. But what is mostly important when we talk about skills of engineer, or what we need to develop in India to address this market, is real skills of software engineering and test engineering. We have to understand how the testing has to be done, what is important to assure the coverage of the testing, right? Everybody is saying, how do you know how much simulation is required and all? And that comes from that real understanding of the test engineering, that we all have to develop the skill and contribute towards this.
All right, thank you. We have about 17 minutes to go for the closer of this roundtable. So what I'm going to do now is switch over to some questions that we've received from our delegates. This is a generic question that I have from Devendra Bharadwaj. What is the possibility of implementing critical ADAS features which are infrastructure agnostic, like automated emergency braking, occupant monitor system, and speed assistance control? Bindu, would you like to take that?
Agnostic of infrastructure, is it? Okay.
Yeah.
And the question is, what is the possibility?
Possibility of implementation. Yes, possibility of implementation in India.
I think Ujjwala would also have to help me out on this. How would we modify, or how would we customize an AEB functionality for India? So there are certain specifications that are there, and if you were to take it in its let's say it's as a standalone software as a product kind of a thing, or a standalone software that is agnostic of the hardware it runs on or the environment that it is supposed to operate in, it is very possible, right? Like I said, anything can be designed right? A lot of AEB functionality is based on avoidance of false positives. So basically, you do not want to activate that due to some erroneous, let's say, misjudging that there is something there. And you just actuate the braking. You want to avoid that. So the specifications run a lot with respect to avoiding unnecessary actuations, and that is what happens when you start with the level 1, level 2 kind of automations, right? Automated drivings. So I think in an absolute sense, yes, it is possible. I think what you will deal with is the environment that you run in. And if you have too many of these occurrences and you're using the same software, right? You have tuned it, you're trying to do the best you can. But in the environment you run, anything that could cause a false activation of an AEB, right? It actually brings down your compliance to the test or the certification. So I think that you cannot do something agnostic of where you're running it or what is the target market. It is just not possible because it has to be defined and certified for that market.
Right.
And so, yeah, so that's one answer. What I wanted to link to, because very close to my heart, is what is required. So sorry for this. What is required for our engineers to be prepared to work in the ADAS environment is, like Manaswini was saying, it is so software intensive, right? You must be really good at software engineering, or let's say create large code. Or now, as you go from the level 1s to the level 5s, right, of automated driving, the ecosystem or the enablers, the tooling, the data loop, the data pipeline is as important as the algorithm itself. Because you are doing recursions in your algorithms and you're trying to improve it, and it's a continuous loop. You fail, you take what you failed, you put it back in, plug it in, fix it, run it again. So the enablers, the simulation environment, the tooling that we create is as important as the algorithm. And we need people who are able to understand this, who are able to engineer this whole thing together, right? And then they have to be very good at software. So I think I needed to answer this part also, because it's not where before the product was everything. Here the ecosystem is everything in which the product is birthed. Yeah, so yeah.
Thank you. Anyone who wants to add to that?
Dipanshu, I wanted to
Yeah.
add to that previous question about AEB. I think I agree with what Bindu said. Certification is also going to be the key. So great, you can put together your system, but the regulatory authority has to believe in your system and has to have the wherewithal to exhaustively test and categorically say this is done. Your AEB is fully functional. I'm not sure we're fully prepared for that. And the AEB standards, do they have to be customized to our distances and our speeds, and how do we manage that part? So I think while the technology behind AEB is fairly well defined and it can be engineered, how you get that into practice onto a system, get it certified, get the customer to trust that, I think that's going to be the much bigger issue we all need to tackle.
Right.
I will add one point, Dipanshu, you allow me.
Yes, yes, Ujjwala, please go ahead.
Homologation is definitely part, but what a homologation really ensure that it is more effective in the Indian use cases. I think connecting the Indian use cases by itself is a challenge, and that is what has to be converted. It's not like homologation is only ensuring that. So how do we effectively cover the Indian use cases and make them more practical is really important. And India being so wide, and what we can really bring in is a few selected part of it. So I go back to what Tarun was saying actually, where what is really important for us has to come on board, and that is what I agree personally also. Technologically, we can move on multiple segments. We can claim on we have these technologies, we can claim on these infrastructures. But what makes me effectively do that my accidents from 100 reduced to 50%. So it is very important. When we are talking about AEB, I would also like to mention that for AEB, we would like to have the ABS and probably ESP as a mandatory requirement. Do we have the vehicles with that? first of all on the road. So those technology have to come, or should we go stepwise with the collision warning and then AAB? We always have been debating whether we want to go incremental or we should leapfrog, and that is where the changes will always be there to answer. But I believe creating environment, creating the use cases for the Indian application is the biggest challenge that we have to really cross if we want any technology on ADAS to be successful. And there were actually, I'll go back to my first point where the collaboration is necessary. It cannot be any company, any organization which will create those use cases. It can be only a aggregator, like ARAI can be aggregator for getting those, but everybody has to contribute to create those use cases and convert into the scenarios in the right way, in the covering Indian aspects.
Wonderful. Before I move to the next
small
question,
point on my side,
yes,
just a small point, sorry. That
yes, please.
AEB infrastructure perhaps may not be such a big challenge, but the driver's behavior on the road could be a much bigger challenge. Mr. Bindu asked me for some examples when we did testing. So maybe the way we negotiate a roundabout at high speed, the way we come to maybe 3 to 4 meters, 5 meters at 80, 90 kilometers and then try and overtake a vehicle. And of course, on oncoming traffic on the same lane. And on highway where the max speed is 120, you have pedestrians suddenly coming on. All those scenarios are perhaps extremely difficult to take care, and which are very, very unique to Indian driver and road users' behavior. So to me, that seems to be a bigger challenge than infrastructure per se.
Sure. Thank you. Now, before I move to this next question, I would like to request our delegates to participants to send in their questions. If there are questions that we can't take during this roundtable, we will try and send you the answers later. The next question is from Mr. Varun Katre. He says, in Europe, there are many consortiums formed to capture the use cases for virtual testing. Is there a possibility to have a similar consortium to capture India-specific use cases? Who would like to take that?
Of course, possibility is always there. Why should there be no possibility?
I think the European consortiums are not also anything different from a consortium comes out of the OEMs who actively take leads, and other ecosystem partners join and contribute to the consortium to define, like if he is referring the open scenario, open drive standards, which is defined by the ASAM consortium and all. I think here also there can be a consortium formulated. I think ARAI and OEMs could take the lead, where all the ecosystem partner will contribute, and that becomes the standard for India. It's nothing impossible to do. Yes, it is doable, and somebody should just take the first step to do it.
So do I see a hand going up? Someone saying that, yes, I will take the lead.
I think I think there are some initiatives from government. I'm not sure I know everything, but Niti Aayog and few are happening doing. But unless I would say that the OEMs take the lead, it never becomes a reality here, because again regulations become a regulations, right? It's a paper. So and the difference that you see in ADAS AD is also in Indian OEMs are still in the buy mode, right? They are still integrator, buying black boxes and putting it together. However, in the globally, the OEMs are owning the ADAS AD as their own, right? So that's where they are participating in the consortium. They're owning the fact what should be regulation, what should be use cases to test and everything. I think that's a needed, and we have the largest OEMs in India where it is possible to take that first step. Yeah, all of us should make an effort. See.
Right.
On a limited scale, ARAI is doing it, but again, as I said, it is alone is really very difficult. We are also talking with SIM and trying to get partnerships going. So there have been discussions happening to do that. Of course, the funding is always a challenge to go for a bigger ones. But yes, we are trying to do that. And it is necessary.
We go back to the points that you had made initially about taking that collaborative approach where all stakeholders come together. And this is probably one of those subject areas that you could make a start. Vasishtha Bhargav has a question. What are the potential risks and uncertainties associated with the implementation of ADAS in less developed nations and its effectiveness in geographically sparse environments? Potential risk and uncertainty in less developed nations.
Risks and
I don't know, of course, the context of less developed, but I think the risk is of traffic conditions and not having a system which is ready for that specific region's traffic requirements. I think it is perhaps not linked to, perhaps less developed means the traffic also is more chaotic. That's what he feels, and I'm sure. I mentioned some of the areas I think where India-specific risks are there. Other point also, one other way of looking at it is somebody mentioned about false positives. So I think if a system actually keeps on giving too many false positives, consumer will ultimately want to shut it off. So that's another way of looking at it, that you have to give something which works, which doesn't annoy the user. If I'm getting, for example, we have tried to use some.
Yeah, if you implement AB in Bangalore, always AB engaged. There is no driving, right? So it has, it has to be customized for the local. Yeah, the answer is, I think it's not about the developed or non-developed countries. It's about tuning the algorithm and developing it against the local scenario. What Tarun is also saying, that we need to understand what is the road behavior against driving, and we need to fine tune the algorithms for that application.
Right.
Yeah, I would like to add one point here that, sorry, go ahead.
No, just on the lighter side, right? So a lot of simulation programs, we try and simulate the ego vehicle, the driver part, the traffic participants, which is basically the other cars on the road, and typically you're trying to simulate the driver behavior, right, of all these, and there should be a model to describe the Indian driver. Okay, so I think that if Shanti can solve that, Shanti, we will be really grateful to you.
I'm not sure one model will be able to.
Indian driver model introduced by MathWorks, right?
Yes, yes,
I'm not sure one model would be enough. I just wanted to add on that question that I think it's another aspect is awareness. So if in the underdeveloped countries people are not aware of these regulations and they don't follow any of the rules, AEB is making certain assumptions, and if all of those assumptions to start with are violated because of the lack of awareness, you're not going to be able to have a fruitful system.
True, indeed. All right, I'll have one final question before we move towards the end of the roundtable. This is related to cybersecurity. What are the thoughts on the need and priority of automotive cybersecurity in vis-a-vis ADAS?
Yeah, so it is called dependability. The subject, it includes safety, cybersecurity, and certif and other things. So it is part of the whole dependability. It is not either ADAS or security. It is very much included in the whole solution of ADAS and autonomous as a safety system.
Okay. Anyone else wants to take that?
I think
there are. Okay. Sorry, Ujjwala, you go ahead.
So I only said it's. I agree to Manaswini what she's saying.
All right.
Okay.
Bindu, please. Yeah.
So we have cases where HAD maps, for example, where you are continuously updating the data that is on this map, and you use different localization methods, and you're trying to basically, as you go up the automated levels, right, So you have this continuously, let's say, evolving software also, which is being used on the edge also. So cybersecurity is something that, because you involve a lot of components of the cloud, you basically have providers linked for you to be able to set it up. It is of extreme importance as you go up the automated levels, that your systems, which basically depend a lot on evolving software or content, when we're talking about building content into the software, then yes, it takes higher and higher priorities, and we need to make sure that it is protected.
All right. So we are running out of time, but before we close, I would like to invite all of you to make your final comments on the evolution that we're talking about for ADAS, for an ADAS roadmap in India. Ujjwala, half a minute for each one of you to make your final comments, please.
I think I will finish off on what I started, that validation is a key, and for validation, creating Indian scenarios is a key for the success of ADAS, and for which we have to work collaboratively. That's what I have to say.
Excellent. Tarun, your final comments.
I think we will go towards ADAS inevitably. It may not be very near future, but ultimately we will go in that direction. But I think we should use this time well to work out what is it that we want to achieve, and maybe what is our immediate target. I think if we can go about scientifically doing that, perhaps we'll have a system which will really benefit the country.
Okay. Manaswini, your final comments, please.
Yeah, so I think it's more of localization, which is the need. Most of us brought it up several times, that the technology is ready, but it needs the local fine tuning from regulation, from testing, and from development. I see a faster introduction of parking features than the driving features. Parking assistant, I'm not going to valet parking, but parking assistant and little bit on auto parking features will be more popular, low speed controlled environment and all, then driving features. So that's how we will see how ADAS would evolve in India.
Okay, excellent. Bindu, your final comments.
Okay, so again, with what I started, standardization of behavior, standardization of infrastructure, road features, very critical. But I think the driving factor comes when we believe that safety is really important and we have regulations to support it. So and really it drives the OEMs and the other providers of ADAS systems to really work together then, because you have a common purpose, and that is the biggest enabler that I see.
Excellent. Finally, Shanti, your final comments on the subject of today's discussion.
Yeah, I really enjoyed everybody's opinions and suggestions. I think I still believe virtual testing is going to be an integral part of advancing our contribution to this domain, and also being able to bring the autonomous vehicles to fruition here. It will provide the ability to come up with a set of scenarios that can drive the standards as well. So it has multiple roles. It can help advance and iterate for the development folks also. So it's got a lot of strength for many different facets of this problem, and I think that's going to be the key in accelerating not only us, everybody else who is involved in this game. And lastly, I just of course the Indian driver model is going to be the key, and together we can. I want to conclude with that.
Yeah, it's a wonderful way to actually conclude today's discussion. Together we can. There's a lot of collaboration that is possible, that is needed. And like all of you have stated, all of you are willing to work together to find solutions for the Indian market, not just for the Indian market, but create solutions in India that could possibly become globally relevant and acceptable. I would like to thank each one of you for being such a wonderful panel today, for sharing your insights, giving suggestions, inputs, and I'm sure our participants today have a lot to take back home from this discussion. Before I conclude, my deepest sense of gratitude to our partners, MathWorks. Thank you so much for your support. And as I said earlier, we are committing to continue this discussion on ADAS. We, as a media partner, you can count on us, count on Autotech Review to carry forward this discussion on ADAS. We are setting up a dedicated website, like I mentioned earlier, and we would connect with you the day it goes live. And I would request each one of you to stay connected. We have multiple platforms, of course. We would try and create a community of ADAS professionals on LinkedIn, and I require and I hope that I will continue to have your support. Thank you very much, and stay safe, everyone.
Thank you.
Thank you.
Thank you.
Thank you,
everyone.
Thanks, everyone.
Thank you.